Hello, everyone. Let's get started. Today we are going to learn Laboratory 28 regression model. So please, as usual, please run the first script to identify your hostname, username, and current information. And after that, please input your name, your number, title, and date. Okay. Today we are going to use advertising example to show how to use regression models to explain the models. Okay, so it's a classic regression problem. So we have a data set of the spending on TV, radio, and newspaper advertisement, and the number of sales for a specific product. Then we need to explore the relationship between the parameters, answering the following questions. So can TV advertising spend predict the number, or the radio can predict the number, or the newspaper predict that? And can we use the three of them to predict the number of the sales of the product? Multiple linear regression model, and which parameter is the best predictor of the number of sales for the product? Okay. So first we need to import necessary packages, right? And please write import NumPy, Pandas, statistics, Matplotlib. And next one, you need to import requests and download the advertising CSV file from the internet. Okay, so for instance, here you see there's no advertising CSV file, and you need to use a remote URL and use the request.get to download the content from the website, and then create a new CSV file named advertising and write it. Okay, so write and wait perhaps maybe 5 or 6 seconds, then you can see it on in your folder. Okay. All right, so you need to refresh the folder, and after that you can check the results. Okay, and after that is you can import and display the first rows, check the samples, right? Read it, use a data frame, pandas, read the CSV, and use a describe to have the 5 number summary, mean, value, standard deviation, minimum and maximum, right? About the TV, radio, newspaper, and sales. So you can use some models to analyze the data, right? So first of all, we use 4 variables: TV, radio, newspaper. Oh, sorry, I think this one is not right. So it's about sales, not this one. Sales. Okay, right. And after that, we can get the covariance, right, to show the relationship between 2 variables, TV and TV, radio and radio, newspaper and newspaper and TV, right? So, and you can also use the coefficient to show that. And if you forget that, you can check the lab 2027 to learn the concept of the coefficient or the covariance. Yeah, so about that. Okay, next one, you can answer the questions. So first thing you see here, sales is positive related to TV, radio, and newspaper, right? All positive, not negative. Negative means it's not. Positive means it have some positive relationships, but you don't know the relationship. That's why we need to quantity the relationships, use the models, right? So we still use the statistics models formula API SMF, and we use the same OLS. Remember, ordinary least squared method to show that. And then in the first example, we only want to explore the advertising sales with TV advertising, right? This sales with TV advertising, so sales and then TV, right? is use the column names. You need to use the column names, not the variable name. It's a column name, right? Column name in the data frame. So that's why here sales as is in upper cases and TV, okay? And then after that, do the fit, initialize and do the fit, okay? So you can write, and perhaps you need to use the, maybe wait a few seconds. And after that, here initialize and then do the fit, right? And then you can predict, right? To get some predicted results. And you can show that use a linear line, and then with the raw data, you can check it. So as you see here, this one is predicted, is a red line, right? R means the R is a color, red, okay? So here O means they are all dots in blue color. Blue is the default color. So this one, scatter plot, is actual data in blue dots. Regression line is the red line. So you can check the results here. And what can you learn from this figure? So please run the codes and read it and ask yourself first. So what can you learn? Okay. Okay, so you see here, it's not quite good, but it can show the basic relationship between the TV advertising and sales number, right? So we can say this model is effective. It can show some relationship, but maybe it's not the best, right? So then we will continue explore. Next one is about, can radio advertising spending predict the number of sales for the product? So we do that again, but the only difference here is we use the radio as the second one as a parameter, right? And after that, you use the same way, but here is predicted values be based on the radio data, and the scatter plot show actual data with the blue dots, and then regression line in red one, right? Oh, so let me see. It's a little bit. Which is wrong. Radio one. Oh, sorry. I forgot to write. Sorry about that. So it's not normal. Okay. Yeah. Sorry about that. I forgot to fit, initialize, and do the and train the model with the data. Okay. And after that, you can get intercept and radio because it's only a linear line, right? And after that, please write, show the results. But in this way, you see it's not very good because you see some blue dots, they are quite far from the linear line, right? They're very far. Yeah, but it can show some of the part of the relationship between the radio advertising and sales, right? So, any questions so far? Or do you have any errors? All right, so next one is about exercise one. So you need to use the third part of the data, newspaper advertising, to predict the product. Okay, so it's very similar. So you can check the result, you can check the codes of the TV or the radio, then you will know how to use the newspaper advertising to predict and then plot the figures. Okay, see TV and radio, we give you the codes to sales, and then you need to answer the question about newspaper and sales. All right, so it's about the exercise one, so you need to finish by yourself, but I think you only need to revise some keywords of the codes. It's not very hard, okay? Yeah, it's exercise 1. Next one, you must have another question. So perhaps this is a, so can we use 3 of them? So we have TV, radio, and newspaper. So can we use 3 of them to predict the number of cells? It means it's a multiple linear regression model. It's not a single regression model. It means you have more than one predictor. So it means you in the first 3, in all these 3, you only use the YE is alpha and plus beta 1 x beta x1, right? So alpha is the intercept and beta is the slope, right? But here we have multiple parameters. So alpha, intercept, and beta 1, slope 1, slope 2, slope p. So p is the number of predictors. So in this example, we have 3, right? P is 3. So beta 1, beta 2, beta 3. In this case, we can use this formula, right? Cells is alpha means intercept, slope 1 multiply TV, slope 2, radio, and 3 for newspaper, okay? And in this way, we can use another package to learn how to do that. It's a basic model of machine learning domain, right? So we can build a regression model with a radio, newspaper predictors. The first one, you can set the predictors TV, radio, and newspaper, and you can set X means, and Y means you want to predict, right? And you can use the initialize and fit, okay? Because here you set X means 3 parameters, then that's why here you can fit the model, train the model with 3 different predictors, right? So it is a linear regression model. So LM a linear regression model, and here, because you pass the 3 parameters, then it will train them in these 3 parameters, okay? And after that, you can get the intercept and the 3 coefficient. In single regression model, we call it as a slope, and in multiple, we call it coefficient, okay? So betas, this is for TV, radio, and the newspaper. Actually, it's a negative, right? So it's not quite positive, but perhaps it's not the best fit. Yeah, so only the results, okay? So therefore, our model can be written in this way, right? This way, TV, beta 1, what about TV? And this is beta 2, radio, and the last one is about newspaper. So we can predict the sales from any combination of TV, radio, and newspaper advertising costs. Okay, so here, and we show one example. If we want to know how many sales we want to invest in, so $300 in TV, $200 in radio, and 50 in newspaper, we can do this thing, okay? We can ignore the warnings and then do that, show the results, okay? Please make sure here is double squares. It means you want to follow this one, right? Follow the order of these predictors, TV, radio, and the newspaper, and this is for advertising, 200 for radio and 500 for newspaper. And after that, you can predict any sales numbers based on any combinations. Okay, so it's the result. In this way, you can build a linear regression model. Okay, so any questions, or do you have any errors? Okay, so, and the last one, so please answer the second exercise. So which parameters is the best predictor of the number of sales for the product? You need to answer that. You need the first 3 or the last one. So you have 4 choices, right? The first 3, they are all single linear regression model, and the last one is a multiple linear regression model. Which one is better? And then answer your question. Answer why you think it's better, okay? Yeah, so there are all 2 exercises for today's lab. And actually, yeah, I'm discussing with the professor. Perhaps we will have 3 more bonus labs in the following next week. So the bonus labs means you are not required to attend the lab classes. But if you want to get a bonus points, you can finish the labs, but it's not decided yet. Okay, so perhaps we will have the normal labs, but perhaps we will have some bonus labs, and I will update, and I will send you an emails on Monday about the plan after Laboratory 28. Okay. 2, we need to use code, or you don't need to use code. You just need to answer that. Answer with your words. No codes. All right. Yeah, so that's all I want to share today. And please make sure to finish these 2 exercises and submit it by the end of next Monday. Okay. And yeah, so and I will see you next week. Thank you, guys.